Well, welcome. Good day, great day. Actually, this is For Another Day podcast. I am Rick, and I am here today to share with you some interesting research talking about long-term mates. This is Tuesday, February 22nd, 2022, 22222 today. So it comes to be one that we're looking at a study that says men seeking long term mates are more likely to display photos of children and pets in dating profiles. So, ladies, take a listen today and let's get started. So, trying to find a mate. This is a tale as old as time that people have searched out to find the perfect mate or another mate or different mate from what they are in. But today, we turn to social media. We turn to our phones. We take dating apps and profiles to the next level. And so when I saw this research come up, I was intrigued. I was intrigued because so many young adults that I have counseled lately, especially through a pandemic, relate how difficult it is to find a mate, even on the social media platforms and those dating apps that are out there, and whether they swipe left or swipe right or do an assessment to be accurately matched to someone. It's the difficulties of today to truly connect. And so I saw this on SciPost, and it came out January 18th, 2022. And the title read, Men Seeking Long-Term Mates Are More Likely to Display Photos of Children and Pets in Dating Profiles. Now, this new study came from the Evolutionary Psychology Science Journal, and it was dated October 8th, 2021. What they were looking at and what they found was that men seeking long term partners displayed children, dogs, other pets in their online dating profiles, more so than men just seeking short term mates. There was no differences in frequency of displayed dependents, or these other factors. So children, dogs, or other pets, these were known as dependents. So there were no differences in the frequency of displayed dependents between men and women seeking long-term partners. Okay. So evolutionary theories on mating behavior suggest that the different challenges faced by each sex in relation to parental investments give rise to sex-specific mate preferences, interests, and strategies. So women invest more so biologically, um, just because they are the ones that are birthing. Now, this is compared to the men who aren't obligated to give physiologically, like the female, but the male investment often comes with emotional and physical care for the offspring, as well as resource attainment to sustain a family unit. Now, while long term mating strategies involve commitment, biparental investment, so a two parenting investment here, short term mating strategies are characterized by brief affairs with multiple mates, a minimal investment in partners and offspring, especially for the male. Now, men gravitate towards short term mating while women prefer long-term partners. Now, women adopting a short-term mating strategy, they seek direct benefits from the mates, including immediate financial gains and social status. However, women using a long-term mating strategy have a preference for qualities that make a good companion and possibly a good parent, with qualities such as love, kindness, agreeableness, and parenting skills. For example, when faced with multiple potential long term partners, women will opt for an altruistic man. But what these dependents are showing by showing pictures of your pets, these are alive beings who depend on someone for care. And this could serve as a signal of one's ability and desire to provide resources and care. Its cues of investment capacity are particularly prominent for men, given men with children and pets are seen as more attractive mates than those without. This phenomenon may actually reflect the fact that kids and dogs signal financial and social status as well as one's ability to care. Other types of pets, such as cats, require less care and social interaction and thus may not be a particularly strong signal of male investment. So the researchers here created a male and female account on a popular online dating platform in Canada. This platform encourages users to discuss numerous facets in relation to family, occupation, and personal lives. These accounts were used to access profiles of the opposite sex. Now, daters were categorized based on the type of connection they were seeking: long-term relationships versus casual encounter without commitment, which were used as proxies for the mating strategies for long or short term. All daters were situated in Nova Scotia, Canada, and every second profile was selected to increase the coverage of daters. So this study ignored profiles with generic photos, stock photos, nature scenes. It ignored spam accounts and profiles with unclear indication of what type of connection daters were actually seeking. The dependents were quantified by photographs or written statements of children, dogs, pets. Age, education level, as well as the desire to have children were also documented. So this was a sample that had 225 men, 225 women seeking a relationship, and 225 men who were not seeking a relationship. They tried to quantify a group of women for not seeking a relationship, but there was not enough participants in the dating app. So the authors go ahead and do state that there were two limitations in this study. One was that the dating strategy was assumed based on that daters indicated what they truly wanted in their online dating profiles. They were assumed to be honest, which, as anyone that's used them before knows, that not always honest and truthful. Also, the age of the daters was not restricted. So age influences both mating behavior and correlated with fertility, especially for women. So the age variant there was also a limitation. But like I said before, what they found was that men who were seeking long term mates displayed their dependence on the dating profile to a greater extent than men seeking short term partners. Men and women seeking long term mates displayed dependence similarly, as in there was no sex difference in this regard. Men and women seeking long term mates most frequently displayed children in their profiles. Among men seeking long term partners, the most frequently displayed dependent was their children and dogs. So, what does this mean? And how does this relate to you for those that are going online? Women, well, if you're in Nova Scotia, be looking for guys that go ahead and put up pictures in their profiles dealing with their dogs and with their children. They are the ones that you want to go out and date. But for everyone else out there, this is one of them that it gives us just a glimpse into our psyche, that what and how we choose things also becomes very biological, that we're looking for a long-term mate that has these abilities to show I can provide, I can be able to do this. I've done it before. I've got dogs. I've got children. But I'm willing to try it with you. I'm willing to share a part of me with you so that you know this is who I truly am. These are the things that I desire, I find pleasure in, and I want to share. So I would be interested to know from you, the viewers, what have you noticed if you've used an online dating app before? When it comes to relationships, have you found a difference with what was put up in the profile? Comment down below and share. It would be interesting to know. Real dark chocolate and pretzel protein bars that both taste great and nourish us. Nugo offers so many types of bars and cookies for your enjoyment, but I always stick with the best. Plus, it's gluten-free. Click the link below to order yours today. The following COVID information is reported from preprint research needing further exploration. I am not a medical doctor. Should you ever exhibit any medical illness, please seek a medical doctor for diagnosis and treatment. So this article came up and I was intrigued. It comes out of Scientific America. It's posted on February the 7th, 2022. Title reads, COVID smell loss and long COVID linked to inflammation. Hamsters eating Cocoa Krispies reveal inflammation pathways from olfactory senses and symptoms to the brain. So what does this mean? And I really wanted to get into today because so many clients that I've talked to, so many other people, family I've talked to that have had COVID have exhibited loss of the sense of smell. And so it shows that the impaired sense of smell affects approximately 30 to 75% of people from the novel coronavirus. Now, this is just an estimate, and this is a worldwide estimate. Now, this phenomenon that's been happening with COVID for the past 2 years is called anosmia, and that's when the olfactory system dysfunctions, and typically it's temporary, but it can take months or longer for a full recovery. making it difficult to enjoy meals, detect odors such as spoiled food or smoke, or can even signal danger. Now, this study originally was shown in preprint on January 18th, 2022. And what preprint means is they are looking for more relative and related research regarding this. That means it's about to go for peer review to be explored in journal articles. So this is hot off the presses, just out of research out of New York, and it gives a detailed biological explanation for this loss of smell. So the research involved feeding Cocoa Krispy cereal to virus infected hamsters and then confirming the genetic results in human tissue. So the team concludes that infection with SARS-CoV-2 causes severe inflammation in structural cells in the olfactory system, and it thereby overwhelms and impairs the function of nerve cells and other smell related processes deep in your nasal cavity. So what I want to do is make the distinction because there's two studies here that was done. The February 1st study that was produced in Cell, the journal Cell, has actually gone before peer review. The second part, which was the preprint that wasn't done yet, was the follow-up. But there is here an edited transcript from an interview between the senior author, Benjamin Tenover, director of NYU Virology Institute at New York University's Grossman School of Medicine, this was the senior author of the long COVID study, and also conducted the anosmia focused study. So these excerpts here are from the interview between Robin Lloyd and Benjamin Tenover. So Robin asked, how do you test anosmia and other olfactory effects of SARS-CoV-2 infection? And he said, there has yet to be any biology witnessed in manifestations of COVID-19 in humans that we can't replicate in hamsters. So we studied 3 different groups of hamsters: a group infected with SARS-CoV-2, a group that received a controlled substance for a mock infection, and an influenza infected group to provide a benchmark showing the typical immune response to a common respiratory virus. Then we did behavioral tests with the groups, including one that involved withholding food for about 10 hours so that hamsters were good and hungry. And then we took Cocoa Krispies, which hamsters love, and they buried the cereal under their bedding and then timed how long it took for them to grab it and stuff their faces full of it. Among the hamsters infected with the mock or the flu viruses, they all found the Cocoa Krispies within seconds on days 0 through day 14 after the infection. But the SARS-CoV-2 animals on day 1 and also on day 2, they couldn't find the Cocoa Krispies at all. They just left them. So it was very clear that they lost their sense of smell, because by day 15, they were back on track. And everyone was very happy and focused on finding and eating the Cocoa Krispies. We then repeated the experiment, but this time we used single cell sequencing, which lets you see not only all the cells that make up the olfactory system, but also where the virus was going and the consequences of those infections in the cell. So Robin asked, what did the team learn about the details of the mechanism that underlies anosmia? He responded, what the data shows is that the virus is limited to this one type of cell called SUS, S-U-S, or suscenticular cell in the olfactory tissues of the nasal cavity. This cell type performs an important structural role and ensures that related cells called olfactory sensory neurons in the tissue are organized in such a way that you can perceive smell. Now, following a SARS-CoV-2 infection, we find that hamsters have lost more than half of all of their SUS cells in just a 2-day period. So the structure of the olfactory system has just been totally decayed away because of that significant cell death. And as a result, those SUS cells are now just spewing out a great deal of material that triggers inflammation. Now, on day 3, because of the inflammation and damage, janitor-like immune cells called microglia and macrophages come in and engulf the inflammatory material and clean it all up to bring the inflammation invoked by the material back down to a baseline. So then Robin asked, well, what happens next to cause the loss of sense of smell? And he said, the adjacent olfactory sensory neurons, which detect odors, typically spend 80% of their transcriptional or gene copying bandwidth dealing with olfactory related biology, such as processing smells, making different smells related to receptors. Now, suddenly they're bombarded with all this other inflammatory information that's demanding. So let's say 50% of their transcriptional bandwidth. As a result, the neurons are forced to avert their attention from olfaction and resulting in a dramatic loss of production for the components needed for smell, culminating in anosmia. So the cells are still there, and the cells aren't dying. They're just busy doing something else. And as a result, you will lose your sense of smell because so much bandwidth has been taken away. And your olfactory machinery can no longer comprehend such a complex process. And so for a brief period of time, maybe 3 to 5 days after infection with SARS-CoV-2, many people lose their sense of smell. But by then, the janitor cells have cleaned up all the inflammatory material, and the progenitor cells replenish the population of SUS cells that had died off. And so most people get their sense of smell back. So Robin asked again, so how does anosmia research relate to the proposed cause for long COVID in your second new study? And he said, in this study, it goes one step further. Yes, all the olfactory system inflammation can persist for a long period of time. And the longer it stays there, the longer you respond to it. And there are many reasons why the inflammation might last a little bit longer in certain individuals. But what we find is that the inflammatory response in the olfactory system can actually travel into the brain. So we sequenced all the organs from SARS-CoV-2 infected hamsters during the first week of infection. When the virus is actively replicating, as well as weeks and months thereafter, in addition to different organs, we also performed the same type of analysis on individual brain compartments, like the prefrontal cortex, the striatum, the thalamus, the cerebellum, the trigeminal ganglion, and even the olfactory bulbs. These analyses demonstrated that the entire body shows signatures of inflammation for weeks following a viral clearance. Now, while this inflammatory response does diminish over time in the body's organs, These transcriptional changes persist much longer in the olfactory bulbs, in the striatum, in the thalamus, and in the cerebellum. And what's more is those transcriptional signatures show a loss of a number of metabolic activities as they maintain this heightened inflammatory state. The changes in metabolism really scarily looks a lot like the signatures that come out of Alzheimer's or Parkinson's or ALS or other neurodegenerative diseases. And in hamsters, we can correlate the ones that have the activity and also the ones doing very poorly on behavioral tests. So the fact that they were behaving differently would suggest that they're also having some kind of cognitive change or behavioral change as a result of this prolonged inflammation that has penetrated many aspects of their neurological circuitry. So Robin asked him, what are the implications of these findings for the treatment of long COVID? And he responded, now, by the time a patient with COVID is in the hospital, the problem usually is no longer replicating virus. It actually has all to do with inflammatory material that's still there, causing your body to overreact to it. And so we treat it with steroids to set everything back down to a baseline. This would suggest the same thing should work in the brain for people with long COVID. But this needs to first be tested in animals to understand dosage and timing and steroid choice. If researchers found the coronavirus did infect neurons and that long COVID was actually the byproduct of a low-grade infection somewhere in the brain, the last thing you would want to do is to give those people steroids. That would actually lower the innate immune defenses in your brain and allow the virus to build up a bigger armament and start replicating anew in the brain, which obviously you don't want. If you give someone who has SARS-CoV-2 steroids before they've cleared the virus, that's bad news. But if we give steroids that cross the blood-brain barrier to hamsters, they actually shut this inflammation down, and it would suggest that this would also work in human beings. Obviously, we need to do more testing before studying this in people, but we already have a colony of hamsters with long COVID, and we'll soon begin testing steroids and antidepressants to determine possible therapeutic approaches. And so this is the intriguing part, not only from the study, but where research is going in terms of long COVID, not just looking at acute COVID, but the effects of long COVID and where that will take us in terms of research, in terms of diagnostics from medical doctors, and in terms of treatments. So this is definitely one that we're going to want to keep on our radar, to keep watching for, to see what the potential is to be able to help. I'm curious. There was a poll below that asked, if you've had COVID, have you had a loss of sense or smell? And from this research that's happening today, it's becoming more and more evident that the effects are changing us. It's changing culture. I know I've had so many clients that have said, I couldn't smell the taste of food. I didn't like the food that I've always liked. I couldn't tell that the laundry was actually washed and done. It smelled like sewage. So it's interesting where our brain perceives and changes those smells that we've been experiencing each and every day and building since we were infants. So like I said, more research to be done, and I'm interested to hear your comments down below. So once again, thank you for subscribing. Thank you for liking and sharing this podcast today. I want to encourage you to make comments down below to encourage others to come across the information that I'm trying to relate out to everyone, but also to realize that we're in this together. I would appreciate too if you click on our Amazon links and help us to make those small purchases, and it makes a difference through all of our affiliates. But today I wanted to leave you with a closing quote. This is from William Butler Yeats. Wine comes in at the mouth, and love comes in at the eye. That's all we shall know for truth before we grow old and die. Peace to y'all. Talk to you next time.